Hello, everyone, and welcome back to the Boost Your Biology podcast. I'm very excited for today's conversation. So, first up, a little bit about this person. He's a health coach, independent health researcher, and the host of the Energy Balance podcast. Jay Feldman, welcome to the show.
Thanks for having me, Lucas.
Awesome. So, Jay, maybe let my listeners know a little bit about your journey into health optimization and how you became so fascinated into all this sort of stuff.
Yeah, definitely. So for me, it started mostly in the fitness world. I was pretty young and, participating in sports and saw people also, getting buff at the gym. And of course, when you're young teen, you that's what you aspire to. And so that's kind of where my health journey began, just trying to optimize my health from a fitness standpoint and using supplements and nutrition. And that really sparked my interest and passion in health. And, of course, it evolved considerably over time. And I went to school pre-med to become a medical doctor and also was progressing in terms of what I was working on nutritionally. So, of course, starting with very much the standard healthy diet of whole grains and dabbled in vegetarianism for a bit and then shifted into paleo as that was becoming popular, and ketogenic diets and intermittent fasting, and going deeper and deeper down all those rabbit holes. And over time, was someone who was always very, very committed to their health and learning about these things, but wasn't feeling as good as I was supposed to be feeling based on how much effort I was putting in, and was seeing a lot of parallels in the approaches I was taking alternatively, as well as what I was learning in school. And as I was recognizing that these things weren't working, I started to kind of shift perspectives a little bit and, looked for alternative views. And what I had come to realize was that all of the approaches, whether it was mostly in this alternative sphere of fasting or caloric restriction or ketogenic diets, or in the allopathic Western medicine model, they were all built on this idea that we need to be fighting against our own bodies, that whatever our body's natural desires are, whether it's a desire for carbohydrates or for eating more, those of course are the worst things. And we're naturally lazy. And so we need to force ourselves to exercise in order to be healthy. And from the allopathic model, you have a very similar perspective where our body's own responses to their environment that maybe involves an increase in blood pressure, an increase in cholesterol or insulin resistance or whatever it is, that is the problem. Our bodies are not smart enough to properly respond to our environments. And so we need to fix that with medications. So I was kind of recognizing these things and then came across this idea that energy is the foundation of our health. And that really changed everything, led to a complete shift in diet and lifestyle and how I viewed our organisms, like ourselves as an organism, as well as our environment and beyond. And so that really kind of jump-started things. And then, after that point, have been working as a coach and researcher to dive further down that line of thinking called the bioenergetic view of health, using that same perspective to help people, optimize their health, reverse various chronic health issues, tons of different symptoms and issues, and on from there.
Yeah, incredible. I think what would be cool is if we could sort of dive into that bioenergetic view of health, and maybe do you want to, I'm curious to know, Jay, was there like an aha moment for yourself, like in terms of like nutrition, or like the penny just dropped for you?
I definitely can't take all the credit. Along the way, you're exposed to various to ideas from all sorts of different people and perspectives. And, sometimes you need to hear something a few times before you explore it a little further. And so there was no individual moment that comes to mind, but there was definitely a period of time where I was really struggling from what I had been doing, right? So dealing with a lot of these feelings of restriction and hunger, I wasn't sleeping as deeply. I was having some trouble with sleep. I was dealing with various microbial issues, fungal infections, things like that, viral infections. My libido was nowhere near where it should have been. Wasn't having the energy and focus and drive in the gym. And those things kind of were beginning to culminate. And, I was really looking for a way out. And so I was more open to alternative ideas and coming across this bioenergetic view, and largely which is kind of spearheaded by the research of Dr. Ray Peat, allowed me the freedom to maybe have some more carbohydrates in my diet and stop with all the fasting. And I was looking for any excuse to be able to do those things. And so once I started to dabble into that realm of thinking, I definitely did not look back because it changed everything.
Yeah, incredible. Well, let's sort of stick on that topic around like carbohydrate intake and metabolism. Do you want to share why being a carbohydrate burner, so to speak, is actually beneficial for metabolism?
Yeah, so there's, these conflicting or opposing ideas in terms of whether we should primarily be burning fat as a fuel or carbohydrate as a fuel. They tend to reflect this larger picture of fighting against our bodies versus, I would say, working with our bodies. And along the same lines is this idea that whether having more energy is a good thing or not a good thing. But if we just look at it in the lens of carbs versus fats, what are the differences? We know that there are quite a handful. And I think when we first started the big picture, I think it's much easier to zoom in. And so when we look at the big picture of when we would naturally be burning mostly fat, it depends on our carbohydrate intake. So when we're eating a lot of carbs, we burn a lot of carbs. When we're not eating a lot of carbs, we'll burn a lot of fat. And it doesn't change too much whether we're having fat there, or I guess I should say it's mostly dictated by carb availability. So whether we're having a ton of fat or not as much, what really matters is how much carbs we're taking in. Because if we don't eat any carbs or fat or protein, if we don't eat anything and we fast or starve, we're going to be burning a lot of fat. So we have this larger context of when carbs aren't available or there's no food available, we tend to run on this backup fuel of fat. And that's a really great adaptation because otherwise we would not be able to survive for very long. Because when we're running on carbohydrates, we can't store very many of them. In general, we're able to store about 500 grams of carbohydrates. If we're eating a ton of carbohydrates, that could almost double depending on the instance. But an average person, we're storing about 500 grams between our liver and our muscle glycogen. And when we store carbohydrates, they're stored with water. We have to store 3 grams of water for every gram of carbohydrate. And so it's not a very efficient way to store fuel. And so when we're using carbohydrates, we have to make sure that we're continually refueling there. But fat, on the other hand, is really easy to be stored. We can store it very easily. It doesn't require a lot of water to be stored with it. And so because of that, it makes for really great fuel when we don't have any food available. So it's really great that we run on fat and can store fat when we don't have food available. But it also comes with certain other adaptations to help us deal with that lack of food and the lack of carbohydrates. And those involve a slowing of our respirations, of our mitochondrial respiration, the amount of energy we're producing. And that allows us to survive for longer so that we don't run out of our fuel stores very quickly and then die if we're in a famine. So that's kind of the bigger picture, is that fat tends to go with a lack of available food, or fat burning tends to go with that. And because of that, it also comes with these adaptations that slow down our metabolism so that we can survive for longer in a famine state. And we can drill into the mechanisms a little bit as far as what's actually going on in the actual oxidation of these fuels that creates this effect.
Yeah, for sure. I'd love to dive into that, and then also sort of maybe link in like the impact that has on thyroid health as well.
Yeah, and maybe just to start on the bigger picture, the first thing that happens when we're shifting toward this lower energy availability from fat burning is that we end up with an increase in stress hormones, and as you're getting at, a decrease in thyroid activity. And that's normal. This isn't really controversial. If you're starving, thyroid activity goes down, fat oxidation goes up, and you'll initially see, big increases in stress hormones. That's kind of our normal physiological response. And that's because, as you're kind of getting at, our thyroid is the main governor of how much fuel we're burning and how much energy we're producing. And so when we need to slow everything down so that we can survive, our thyroid activity goes down. And then vice versa, when we're in a really great supportive environment that has a lot of great fuel available and all the other things that allow us to use that fuel, then our thyroid activity will go up so we can produce more energy and function better. So that's kind of that big picture, but it all starts in what's going on in the mitochondria that is signaling this difference. What's going on that's signaling that we're burning carbohydrates and we want to be revving that engine a lot faster, producing a lot of energy, versus what's signaling that we're burning fat and we want to be slowing down that energy production and our respiration so that we can survive. And there are two main signals that I think are most important to focus on. And so the first of these has to do with the ratio of certain electron carriers. And these are FADH2 and NADH, and then their kind of counterparts of FADH and NAD. And so when we're burning fat as a fuel, and it has to go through beta oxidation first, as opposed to burning glucose, where we're going through glycolysis first, this leads to a production of much more FADH2 with the fat burning side. And generally to the point that it's about 2.5 times more, or I guess the ratio of FADH2 to NADH tends to be about 2.5 times greater from fat burning than carb burning. So pretty big difference. That's 250% difference. Yeah, between the two. So a lot of the energy, or the end point of energy production, is the electron transport chain. And that's when these FADH2 or NADH carriers are dropping off electrons to then produce energy. And FADH2 does so at the second complex of the electron transport chain, and NADH does it at the first complex. So when we have a lot more of this FADH2 dropping off at complex 2, it basically blocks the function of the complex 1. And this has to do with the fact that the electron acceptor there is ubiquinone, and there's a limited amount between the two complexes. And so if you're using all of it at complex 2, there's not very much left for complex 1. And so because of that, when you have this high ratio of FADH2 to NADH, you don't end up offloading very many electrons at complex 1 through NADH, and you end up with a buildup of NADH. And this leads to a very low NAD to NADH ratio. So I know this is a lot of details of biochemistry, but basically the effect that we're seeing here is this difference between fat oxidation and carb oxidation between the FADH2 and NADH ratios then leads to two things. One is, from the fat oxidation side, you're going to see a lower NAD to NADH ratio, and you're also going to see increased production of reactive oxygen species at complex 1 of the electron transport chain. And this NAD to NADH ratio is really the main driver of the speed of how fast we can respire, how fast we can burn a fuel. The higher that NAD to NADH ratio is, the faster we're burning the fuel and the more energy we're producing. And so with the fat, since we have a much lower ratio there, we're going to be producing much less energy. So that's kind of that first piece that's going to lead to the slowing of energy production when we're burning fat.
If we look at, let's say, for example, Jay, we look at this scenario where, again, from a satiety and palatability aspect, most people prefer to combine their carbohydrates with fats, right? So maybe you could sort of explain like how that, what would happen metabolically in the body, in terms of that combination.
Yeah, and that's a very different situation from when we're just choosing one or the other. If we're just on a very low carb diet, or if we're just fasting, where we're forced to burn fat everywhere. But the fact that fat burns a little slower is not necessarily always a bad thing. And it's actually a really great thing when we're looking at our muscles at rest, for example. So when we're at rest, we're not moving very much, or even when we're doing low intensity activity, our muscles are mostly burning fat. And that's totally fine. So they don't need any higher rate of energy production. But on the other side, there are certain areas, certain organ systems that really require a lot of glucose. They can't run on that low amount of energy, the very inefficient energy production from fat, and they need carbohydrate. And that's mostly our nervous system and our brain. And then also our kidneys and liver use a pretty decent amount of carbohydrates for fuel. And so if we're taking in both carbs and fats at the same time, there's no inherent issue there, assuming that everything's working well metabolically. There will just be a partitioning of these different fuels. So a lot of those carbs will be taken up by the liver, stored as glycogen. A lot of them will be taken up by the brain and used for fuel. And then a lot of the fat will be taken up somewhat at the liver potentially as well, but also a lot in the muscles that are mostly using that fuel. And so you don't have any inherent issue having both of them together. I think there's actually a lot of benefits to it. But yeah, that's because our bodies are pretty intelligent in their way of distributing their fuels.
Okay, makes sense. What about in terms of looking at the nuances around different carbohydrate sources, for example, fructose, sucrose, I'm sure you've explored the different types and how they impact metabolism. So maybe do you want to break that down to my listeners, the different types of sugars, and maybe which ones you think are, most beneficial for sustaining or maintaining metabolism?
Yeah, there's a couple unique features or characteristics from the different sugar sources. And so pretty much all carbohydrate sources that we take in that are not starch are a split between glucose and fructose. And then when we're having a starchier source like, potatoes or grains or rice, that's going to be mostly entirely glucose. Whereas again, like fruits or squashes are going to have more fructose. And so there's certain benefits that we get when we're taking in fructose. And the first of those, or one that's worth mentioning, is that a lot of that fructose gets taken up by the liver. And because of that, we end up with a much more balanced response in terms of our blood sugar. So when we take in a lot of glucose on its own, it's going to lead to potentially, depending on how much we take in and how quickly it's absorbed, digested, that could lead to a pretty big spike in blood sugar. But when we're taking in equal amounts or mostly equal amounts of glucose and fructose, a lot of that fructose gets taken up by the liver. And then eventually some of it will get converted to glucose and sent back out. That's going to lead to a much more balanced blood sugar response. So that's one part. And then along with that, also the other piece there is that the fructose is much better at fueling the liver and refueling or restoring our glycogen, which is stored in the liver. And that's basically our brain's storage for fuel because our brain can't store glycogen. So that's super important, right? For supporting like our cognitive capacity and being able to sleep through the night and being able to go between meals and have some stored sugar. And then the glucose is much better for fueling the muscles as well. It doesn't get picked up by the liver as much. And so our muscles will take up more of that glucose. And so if you're trying to recover really well from a workout and restore or refill the glycogen stores in your muscles, making sure to get enough glucose is going to be very important.
Interesting you said that, Jay, about the sleep quality, because I'd like to add in my own experience, like with different diets and things like that. What I've found works, well for me is actually I finish the day with a pretty high carbohydrate meal. And so maybe do you want to explore, like, for some individuals who have sleep issues, how carbohydrates can potentially offset some of the stress hormones and keep that liver glycogen full?
Yeah. So kind of, in the same way that we were associating the pure fat burning with the stress of famine, carbohydrates do the opposite. And so anytime we're going for an extended period of time without enough carbs, our blood sugar is going to drop. And that's going to cause the release of stress hormones to bring it back up. It's a totally normal and helpful response, but it's not one that we want to be relying on because there's a huge cost to the increase in stress hormones like cortisol. And that's something that's pretty well known, right? We know that that's associated with all sorts of disease processes and generally you don't feel too good when that's happening either. It's going to slow down your cognitive function and you might be getting some hot flashes. You might feel anxious or irritable. You're going to feel pretty hungry. You'll have sugar cravings. It's a situation we generally want to avoid. So that's part of why it's so important to be having carbohydrates on a regular basis throughout the day to make sure that we're maintaining stable blood sugar and not dipping into those stress hormones. As you're getting at, when we're asleep, we obviously can't eat throughout the night. And so instead we're left to relying on the carbohydrates stored in our liver, which is the glycogen storage. And so what you're mentioning here, as far as a high carbohydrate meal being really helpful for quality sleep at night, largely it's because we're providing enough carbohydrates, not only for that moment in time, but also for storage so that then throughout the night, we have enough carbohydrates to pull from and basically keep our stress hormones down throughout the night until the morning when we're supposed to wake up. And that's because we're still using fuel throughout the night, right? Our brains are still functioning, they're repairing, our whole bodies are relatively active, so to speak, or at least some of our organ systems are. So we need to have that fuel throughout the night. And when we don't, that's when we tend to have trouble falling asleep or we're waking up throughout the night. Maybe we're hungry or our heart's racing, we're having nightmares. Those kinds of things tend to be a sign of either not having enough stored glycogen due to not eating enough carbs, or, there could be a handful of other factors, but maybe we're not using that glucose very well. So we're running out of it very quickly. And that could be another kind of presentation there.
Yeah. Something else that popped up in my head was the implications for certain vitamins and minerals to assist with like liver glycogen storage and, maintain that capability. So maybe do you want to explore some of the crucial, vitamins that assist with that, liver glycogen storage?
Yeah. So by default, our liver should be storing glycogen really well, but there's a ton of different ways to create dysfunction where instead of that, carbohydrate or maybe fructose being stored as glycogen, it's being converted to fat or going down some other pathway that is not glycogen storage due to some blocks there. And so as you're mentioning, one of those blocks can be nutrient deficiencies. And there's a handful of possible ones, but one that's generally regarded very commonly is choline, being a nutrient that's really important for protecting the liver, ensuring that the fructose that's entering the liver is being used well. And that would also involve storing it as glycogen. Another one, and this is an amino acid that tends to be really supportive here, is taurine. That'd be another one I would be considering. There's a handful of vitamins that can also be involved. Some of the B vitamins, especially vitamin K2, vitamin E. There's different reasons for each of these. So for example, oxidative stress in the liver is going to impair our usage of fructose, drive it to fat instead of glycogen. And vitamin E is something that can really help to protect us there. So, almost all are going to be important. Vitamin A is another super important one. But so yeah, those are a few that come to mind for sure. And any nutrient deficiency will create an issue there.
Well, just another point that you sort of mentioned, I'm really curious to know your stance on like iron and copper, because obviously that's widely discussed at the moment. Yeah, like what's your opinion on like the way in which the body handles iron? Do you want to sort of explore how that can be problematic and what can go wrong there?
Yeah, so when it comes to iron, we know that free iron is generally a problem, right? And that's not always an issue of excess iron coming in, but it rather can be an issue of whether we're properly using it and whether it's staying in the cell. And again, it's very clear that that is a driver, like free iron is a driver of oxidative stress or an amplifier of oxidative stress. So whatever damage is going on, if you've got a lot of iron floating around, that's going to amplify it. It's also something that's going to drive bacterial overgrowth, for example, which thrive on that sort of iron. And definitely something we want to be aware of. And so part of that can be a matter of being aware of how much iron you're taking in, but also as you're getting at, iron requires other factors to be kept in the right place and used properly. Copper is one of those and one of the most important. So if we're worried about iron, we definitely want to make sure we're getting enough copper. And, not so coincidentally, our livers, which do have a lot of iron, also have a lot of copper. And copper is super important for a ton of reasons. It's involved in some of the main complexes that drive energy production. And so making sure to get adequate copper is very important in terms of maintaining proper iron status, but so is general thyroid activity and general energy availability and opposing stress, because when our cells are in energy depleted state, they end up releasing iron. And so anything that's going to keep our cells stabilized, which involves, having adequate thyroid hormone, having enough carbohydrates, having enough energy is really what it boils down to, is going to help improve iron status. And I've seen that. I've seen situations where iron values on lab work like improve considerably just by adjusting thyroid hormone without changing iron intake at all.
Wow, that's really interesting. I'd love to sort of dive into that. And maybe do you want to explain the implications for having sufficient T3 and maybe break down, I understand the TSH, T4, T3. Do you want to explain to my listeners like the functions of each and how we should be trying to optimize them?
Yeah. So our thyroid activity, as we were saying, is one of the main governors of our metabolism. And that's why these markers are so important. And so those three that you mentioned tend to be the three that we're focusing on the most. Another would be reverse T3. And so TSH, just to start, is thyroid stimulating hormone. And so when we're seeing high levels of thyroid stimulating hormone, that tends to mean that we're not having enough thyroid activity. So our body is asking for more. It's asking for more stimulation. That's happening at the pituitary, which is trying to tell the thyroid, hey, we need more thyroid hormone. So if you have an elevated TSH, which really is anything above a level of 2, although the typical reference range is sometimes up to 3.5 or 4 or 5 or 10 even. And so any elevated TSH above a level of 2 tends to be an indication that we don't have enough thyroid activity. We have suboptimal thyroid activity. And then beyond that, as you were saying, we've got our two main thyroid hormones being T3 and T4. T3 is the active thyroid hormone and T4 is the inactive. And so most of the thyroid hormone is going to be existing as T4. It hangs around for a long time. It has a very long half-life. And then the systemic tissues convert T4 to T3 when they're ready for thyroid activity. And one of the main sites that happens is at the liver. We were talking about the liver earlier. And anything that's putting the liver under stress is going to inhibit our ability, or the liver's ability, to convert that T4 to T3. So you end up with a lot of this inactive T4 and not very much T3. And so you're still ending up with low thyroid activity. And this is where the issue comes in as far as supplementing or using a medication that's T4 only. That's normally what's prescribed when someone has hypothyroidism. And the thing is, it works really well if you're just looking at TSH. So if all you want to do is see TSH come down, which is that thyroid stimulating hormone, you just add a bunch of T4, regardless of whether it's converting, whether it's having any real biological effect, it's going to suppress that TSH because there's a sense, the sensor that there's enough T4. And it's really unfortunate because it leaves a lot of people in a state where they're told their thyroid function is normal, even though they feel just as bad as when they were very hypothyroid, because they're still very hypothyroid and they're not converting that T4 to T3. And so in general, it's why I would recommend if someone is supplementing or medicating with thyroid hormones, I would consider using a combination product that has some T3, but also focusing on the things that are going to reduce stress and improve the conversion from T4 to T3, getting the foundations of nutrition and lifestyle in a good place so that you're rectifying the issue that led to the hypothyroidism in the first place. That hypothyroidism is not random. It's not just genetic or something like that. So that's another issue with just throwing T4 at the problem.
I know before you mentioned the light correction of someone's iron panel just by introducing thyroid hormone. Curious to know about what else have you seen? What else have we seen in the literature, or maybe even yourself with clients, some of the changes that have occurred just by introducing or correcting someone's thyroid hormone status?
Yeah. So normally, I prefer, because if someone's in a state where they're pretty hypothyroid, we tend to see other labs that are off too. A lot of glucose metabolism issues. So maybe high hemoglobin A1C, maybe high fasting blood sugar. Generally, you'll also see elevated lipids, high cholesterol, specifically high LDL, and maybe high triglycerides as well. And so ideally, I would already like to see those things heading in the right direction before supplementing with the thyroid, because we're working on getting the foundations in place. So that would ideally help to correct some of those issues that, some of the drivers of that state in the first place. But, even after that, I've definitely seen huge drops in cholesterol levels by administering, having someone take thyroid hormone. And again, talking about a T3, T4 combination here. But yeah, definitely seen big drops in cholesterol, which used to be something that was very, very widely recognized in the medical community and has fallen by the wayside, probably due to the introduction of statins. But yeah, a relationship that used to be very, very well known is that high cholesterol goes with hypothyroidism. Administering thyroid hormone lowers cholesterol. I think there's studies talking about that from maybe the early 1900s, 1904, 1906, something like that. I'll have to send you over a paper talking about that. So that's a relationship that's been known for a long time. I've certainly seen that. And normally it's something I'm very much looking for, where if there's not a good drop in cholesterol, and I'm saying elevated cholesterol, if someone's looking at maybe 250 or above, even 220 and above, depending on their age and health, if that's not shifting when they're introducing, they're having thyroid hormone, that tends to be a sign that something's off, because that should be a natural response to increase thyroid activity, because it increases the usage of cholesterol and it reduces the release of LDL and the need for it. Well, to an extent. It gets a little tricky when we're looking just at what's going on in the serum. But yeah, so that would definitely be something I would look for, and improvements in glucose metabolism as well. But these are all things that we would likely see going into thyroid supplementation anyway.
Yeah. And also as part of that, Jay, I guess, as you mentioned, improvements in glucose metabolism, I'd imagine then their glucose tolerance and their ability to handle more carbohydrates increases. And therefore, with better tolerance to carbohydrates, they have better ATP output, I guess, right?
100%. Yeah, absolutely. I mean, that's the main determinant of insulin sensitivity, of blood sugar regulation, of glucose metabolism, is how well we're converting that glucose to energy. And thyroid is one of the main drivers there.
So then I guess when we're looking at the thyroid, let's say outside of looking at a thyroid panel, from biofeedback wise, like I know the most common one is like assessing temperature.
Mhm.
Yeah, curious to know like how much emphasis you place on body temperature or some other biofeedback metrics.
I think temperature is generally not necessarily a good place to start, but it is a good indicator of thyroid status initially. It's an indicator that I've seen not to always correlate too well, or it sometimes lags behind when there's progress, but it does tend to follow. And, increase in metabolism, increase in thyroid activity does tend to increase body temperature. So it is something I would look for, as well as pulse as well. But they do get to be tricky. There's a lot of other factors that can affect body temperature and pulse, like the weather or the ambient temperature, what you just ate, or stress hormones. So it's not always a real clear indicator, but I do like to use those in conjunction with others. But nearly any symptom that we could be experiencing, whether it is related to like sleep, insomnia, waking up throughout the night, not storing glycogen very well, or dry skin, or hair loss, or any sort of autoimmune condition, any sort of neurodegenerative condition, allergies, virtually anything we could come up with tends to have a very clear relationship with thyroid. Another huge one is gut health. So like small intestinal bacterial overgrowth, very tightly tied with hypothyroidism. So, again, insulin resistance, I would even go down the line of cancer, fatty liver disease, depression, and like various mood symptoms all can come back to thyroid activity. And it's really amazing to see how much those things can change when somebody goes from hypothyroid to euthyroid, which just means that they have normal thyroid activity. And of course, the solution there is not just throw thyroid hormone at everything. It's fix the foundations that led to hypothyroidism in the first place. And if thyroid hormone is needed on top of that, then that's great. And, we want to use that effectively and not just throw T4 there. But ideally, we can do a lot to improve thyroid status without going immediately to a supplement or medication.
Now, obviously, at the moment, a lot of people are utilizing some of these forms of hormesis. I know you mentioned a few already, things like fasting, low carb diets. One that I'm really curious to dive into is actually cold thermogenesis and, cold water therapy, things like that. Curious to know, like, is there research on how that affects thyroid hormone output? Yeah, what have we seen?
That's a great question. So the cold thermogenesis research tends to revolve around a couple of things. One is the activity of certain pathways that are specific to cold, like cold shock proteins. You also tend to see increases in all of the stress activity, sympathetic activity, which leads to increased energy expenditure. So that's normally pointed to as one of the main benefits, is you're burning all these calories through, via cold thermogenesis, but you're doing that just by activating the sympathetic nervous system. There's a lot of ways you can do that. There's a lot of ways you can increase adrenaline and increase energy expenditure. But I would argue that's really not what we want to do. I would say that that's not at all the same as increasing our metabolism. At least when I'm discussing our metabolism and our energy availability, we're increasing the energy available in a structured way to increase our function. We're not wasting excess energy on heating our bodies up after they're very cold. Of course, it's better to do that than not. We don't want to stay very cold. But, interestingly, there's a study that I've seen cited in favor of cold thermogenesis, but it kind of goes along here where they mentioned that a lower body temperature was associated with longevity. And in the study, what they actually did was they had, I want to say it was some type of rodent in a very warm environment, and their body temperature came down and they lived longer. And so it's almost the exact opposite of what we're doing with cold thermogenesis, where what it's essentially saying is if we waste less energy on keeping ourselves warm because we're in a warm environment, then we live longer. And so it's not about how much energy we're using or wasting. It's about how efficiently we're producing it and how much is available to actually improve our function. And I don't see a situation where cold thermogenesis supports that. You were asking about cold, specifically cold and thyroid. And I'm sure that I've seen some studies in that relationship, and maybe you've seen them more recently and would want to share. And I could share my thoughts, but I don't, off the top of my head, don't remember what sort of effects they're seeing.
I think from memory, there was a difference between the acute effect. So like post cold therapy exposure having some sort of impact on T3 levels. There's other studies where they look at like swimmers, like doing long swims in cold oceans, how that affects their metabolism. But even I'm a little bit confused myself. I think chronically it makes sense that it's going to be harmful. metabolism. But that's just what I perceive. If somebody's doing it every day, compounded with like daily stresses, like you said, it's a very powerful way to stimulate the sympathetic nervous system. I mean, like, and but for some people, they love that effect. You know, some people that are like potentially like have that low sympathetic output. Some people love that buzz that they get from it, you know?
Yeah. And there's something to be said there, right? If we're naturally lower in energy and we need that cup of coffee on an empty stomach or kind of the fasted workout or something like that to get us going, that's important information. And I would just rather get that person to a point where they're producing energy effectively and they're feeling like they have a good amount of energy to use without needing to drive it through those backup pathways, because those backup pathways come at a cost. And as you were saying, most of the time when we're doing anything that drives stress, we see this stark contrast between the acute effects and the chronic effects. Acutely, you're going to see increased energy expenditure, increased mitochondrial respiration. You know, we were talking earlier about the NAD to NADH ratio, and you actually see an immediate, like after it gets very low, you then see a rebound effect because you activate all these backup NAD salvage pathways. Like it's a very cohesive response to oppose that stressor so that we can get back to a state where we actually have enough energy to function. And that's great. But we don't need to do those things to increase our respiration and to produce more energy. And in the long term, we see the effects of those, which is that they do depress thyroid activity. They do reduce the amount of energy available for our brain to function well or our digestion to function well. And, you know, we see those costs over time. It just initially looks great.
Yeah. Also, as part of that, Jay, I guess I'd be curious to know, like, those that can tolerate the cold, apart from having more brown fat, for example, or I'd be curious to know if those that can tolerate, you know, cold therapy and they just seem to, they get by and it's like, I'm not even feeling it. Whereas other people that are like really sensitive to the cold, maybe there's a massive difference between their thyroid hormone activity potentially.
Yeah, potentially. You know, if you would think if somebody has much better thyroid activity, they would probably be more tolerant to it. Yeah, it's, you know, playing a bit of a guessing game here. But the reason why I'm hesitant is because sometimes when we're used to a situation where our metabolic rate is very high, we're more sensitive to when it comes down. But something like cold thermogenesis wouldn't bring it down, right? It would be keeping it high and just maybe activating less of a sympathetic response. And that is something that definitely happens. So when we're hypothyroid and we have lower thyroid activity, we're way more sensitive to the stress hormones. So it's not always a difference of how much are being produced, but our response to it definitely changes. And so you can have like a really dramatic response to stress when you're hypothyroid versus when your thyroid status is better.
Yeah. And also as part of that, Jay, I know we went through TSH, T4, T3, and then you mentioned that final one, that reverse T3. Now we can sort of circle back and link that, the stress picture, cortisol, you know, does cortisol impact reverse T3? And maybe sort of explain what is reverse T3?
Yeah. So when we have T4, it's essentially got three options for what it can do. One is it just stays as T4. The other one is that it gets converted to T3, and that's kind of the normal ideal pathway. And then the last option is it gets converted to reverse T3. And there's a bunch of what they're called deiodinase enzymes that drive the conversions from T4 to T3 or to reverse T3. And as you were saying, cortisol is a main factor that affects the enzyme activity. And what it does is it shifts the conversion from T4 to T3 to instead be converted to reverse T3. And while T3 is the active thyroid hormone, it helps to keep our metabolism high and is related to so many aspects of better function. Reverse T3 is the opposite. It's not active. And so when we're seeing elevated reverse T3 in labs, for example, it's a sign that we're not converting the T4 very well to T3. And instead we've got excess stress, maybe excess, you said cortisol, estrogen is another factor I'd be considering there. That's going to lead to elevated reverse T3 from, you know, conversion from T4.
Interesting there. Like, it makes me wonder, like, what is the actual, is it a backup, you know, sort of a backup hormone? Like, why does the body produce a hormone that's essentially like a lemon?
Yeah, it's a good question. I wonder if it has some opposing effects. I wonder if it has some suppressive effects that maybe are just less recognized. But yeah, I'm not sure.
Then I guess like if we look at, I know you mentioned estrogen just briefly then, and like testosterone, things like that. I really want to focus on how thyroid hormones can influence like these sex hormones. Because I know you said like, it can be so far reaching in its effects that it can affect libido, sexual functioning, and things like that. So maybe do you want to sort of link in how thyroid hormones affect some of our reproductive hormones?
Yeah, we've got this really intricate web between all of these sorts of hormone messengers. And that's what the hormones are, right? They're messengers that help to signal to other parts of our body where we're at systemically. Are we doing really well? Are we struggling? Is there enough energy available? Is there not? Which is really what it kind of comes down to. And they all tend to work together toward the same goal, right? It's not like they're each is just random and we have these random associations between them, but rather they all tend to work in a pretty cohesive, intelligent fashion. And the stress hormones, especially, I think are a good place to start because it's very clear to know what they're indicating. And what we happen to see is that not only do they inhibit like thyroid production, they also inhibit proper T4 to T3 conversion. They also happen to have the same or parallel effects with the sex hormones. So they tend to be pretty effective at lowering testosterone production. They tend to drive excess estrogen production. And you then see that kind of same relationship between the sex hormones and thyroid as well. So you tend to see that, the androgens are going to have that reciprocal relationship with thyroid activity, where they're both going to kind of increase each other, and the opposite with estrogens. And there's obviously details there, but to kind of like generalize, that's how I would think of it.
Yeah, because I'd imagine I've heard it myself, like some people that go on, thyroid hormone replacement or they go on the grains, they mention that they're, perhaps they were trying to conceive and now fertility's improved. And so this is an extraordinary effect that I guess is neglected by mainstream medicine. They don't discuss this at all,
Yeah. And it's tragic, right? It really is. And yeah, it makes sense, right? That the thyroid as kind of this larger governing hormone will have a massive impact on the production of just testosterone if we want to keep it just at that. And I want to say that you definitely see a relationship with ATP availability in testosterone. And I want to say that you'll see T3 stimulating testosterone production as well.
Now, also, I know you outlined some of these polyphenols. I'd love to get your opinion on. Like one that's quite well known is resveratrol. I mean, from what I understand, resveratrol is trying to activate a lot of the same pathways associated with fasting. So do you want to sort of link in, what's your stance on resveratrol and how does it affect the body?
Yeah. So resveratrol is naturally found in very small amounts in foods we would eat. So grapes would be a major, or one of the main foods that are considered to have resveratrol. Same thing with wine, of course, coming from grapes. But the amounts that are in these kind of foods are tiny compared to the amounts that are supplemented. And this happens with a lot of polyphenols, which is that these polyphenols are essentially defensive compounds from the plants, and they work by basically having mildly toxic effects. And this is great because it prevents these certain parts of the plants from getting eaten by bugs and pests and fungus and bacteria that, are trying to take advantage of the plant. So these are really helpful defensive compounds. And when we get them in these normal amounts in our food, they make it down to our gut. We tend not to absorb them very well. And they're able to kind of help shape our microbiome and kill off some of the harmful ones and support, the growth of the beneficial ones by basically allowing for that competitive impact by reducing the growth and maybe even killing the harmful ones. So that's what happens when we're taking in polyphenols, typically in like a regular fashion, just from foods. When we decide instead to take massive doses of these polyphenols, we tend to see them being absorbed considerably more, although even resveratrol is not absorbed well, or, they always have to add in things to help increase our absorption of these polyphenols. Like black pepper is a very common one. And then we tend to see more of their toxic effects playing out. And some of them have some benefits as well. It's not like a clear all polyphenols are inherently toxic. But resveratrol especially seems to be one that is activating pathways that we ideally would not want to be activating. And so they tend to be activating these hormetic pathways, a lot of the ones that are signifying stress and are sometimes driving backup energy production, but are doing so at a cost. And yeah, we can kind of dig into maybe the sirtuins a little bit and that the whole side of things. But in general, I'd say resveratrol falls into that category.
Yeah, well, I guess like resveratrol is typically recognized as a longevity polyphenol in the sense that it's activating AMPK and conserving energy. So maybe do you want to sort of explain that, like resveratrol acting as a SIRT1 inhibitor? Yeah, sort of break that down.
Yeah, and as you said, increasing AMPK and increases nitric oxide as well. A lot of these drive uncoupling too. So a lot of these things that are all considered to be generally beneficial. I think it's easy when we look at AMPK, right? Because that is very clearly, it can be activated by oxidative stress by reactive oxygen species, but largely is increased by ATP depletion. When we deplete ATP, we increase AMP kinase. And again, just like we were talking earlier with cold thermogenesis, this is great in the short term because when ATP is depleted, we need to have these backup pathways to restore our energy availability. And as you were kind of saying, it acts along the lines of energy conservation, like in the long term, right? And there's a handful of associations here that kind of have to break down to get into the details of why it's not as simple as activating these backup pathways increases longevity, which is kind of how it's made out to be. And normally what we're seeing is you activate these pathways in, much like lower organisms, like you see it in C. elegans, for example. And then we extrapolate that to think that the same pathway is going to be beneficial in us humans. See similar things in rats, like, you have calorie restriction and that leads to an increase in longevity in rats. And it also activates these pathways. So these pathways must be good. There's a lot of association going on there. And the problem is, or I shouldn't say association, a lot of assumption built in there. And the problem is not all of those are built on solid footing. And so just as an example, like it's true that activating these pathways will increase longevity of C. elegans, which is a model organism that's used for longevity research quite often. And it's a nematode, a tiny little worm. And you can stress it out a lot in all sorts of different ways and increase its longevity considerably, by reducing calorie availability, reducing glucose availability, using these types of compounds, stimulating these adaptive pathways. But the way that it increases longevity, the way that these worms live longer is that they enter a hibernation state called dower. And in this hibernation state, basically they don't function at all. Their energy production is way, way decreased. They shift from glucose burning to fat burning. They're essentially non-functioning. And in the wild, that would not be a great thing to have happen. It might allow them to survive, really stressful situation, but they're not actually living during that time. And they wouldn't be viable, right? And they would be much more likely to get eaten or killed or whatever it is. In a lab, in a controlled setting, this just leads to an extended period of hibernation and longer lifespan. So we tend to see those sorts of huge confounding variables where we made all these assumptions built on research in those sorts of organisms, but we really can't extrapolate that to humans because A, we don't hibernate in that way, but B, we don't want to be hibernating that way. It's not actually representative of an increase in longevity and function and lifespan. It's really the opposite.
Yeah. What's that state you mentioned, that entering into a dower?
Dower, yeah. It's DAUER.
DAU. And is there like an equivalent state for humans?
No, there's not. Although, you see a lot of the same, to a lower extent, but you see the same responses in terms of turning down the electron transport chain activity or energy production, shifting toward fat burning, decreased blood flow to certain areas, things like that. But we don't actually hibernate like that, right? Bears hibernate, it's not exactly the same as dower, and kind of in a parallel way, they require certain drivers of stress pathways in order to get into the hibernation state. They need a lot of omega-6 polyunsaturated fats to get to that situation. They need a lot of serotonin. So a lot of the same mechanisms that allow for hibernation, are universal. And in some animals, they actually cause a true hibernation. In humans, they just cause hypothyroidism and low metabolism and generally low function,
Yeah. Well, it's funny. You literally just mentioned serotonin and I was like, oh, he brought it up, but I'm going to have to save it for another podcast because we could literally probably spend a whole hour talking about serotonin in relation to hibernation and thyroid hormones and stuff. But Jay, I'd love to finish off by asking you one final question, and that is like, if somebody's looking to optimize like their metabolism per se, like if there's like one final maybe like take home message or critical thing that people need to understand, maybe it's a principle. Yeah, just share that with my listeners.
Yeah. So in terms of principles, I would say that we want to be looking at what we're doing in terms of nutrition, lifestyle, supplements, in terms of those effects on energy availability. And both short-term and long-term, of course. And so when we do that, we come to certain conclusions like that we want to make sure we're eating enough carbohydrates. We don't want to be fasting or going on a low-carb diet. We want to be using that energy in a constructive way, which maybe involves some exercise, but maybe not, excessive amounts of exercise or wasting huge amounts of energy on whether it's physical activity or cold thermogenesis or something like that. That helps to dictate what types of fats we want to take in. I mentioned the polyunsaturated fats. There's a lot of kind of practical pieces that I know we didn't dig into as much. We were talking more theoretical here. And I think on the theoretical side, the most important piece is considering energy as that foundational piece that drives our health. And on more the practical side, if you don't mind me plugging, I have a free mini course where I do dig into those practicalities a little bit of certain things we want to keep in mind in terms of nutrition and exercise. And so if you don't mind, I can point your listeners in that direction.
Yeah, for sure. Make sure to leave those linked in the show notes. I was going to ask actually if my listeners, want to reach out, get in touch with you, where can they find your work? I'm following you on Instagram. You've got a great page there. So share all that, please.
Thanks. Yeah. So for that free mini course, it's a 7-day mini course, again, going through some of those practical pieces for increasing thyroid activity, increasing metabolism, getting better sleep, all of that, resolving gut issues. And so you can head to jayfeldmanwellness.com/energy for that mini course. And my website is jayfeldmanwellness.com. You can find a bunch of articles there, free articles, links to my podcast, which is the Energy Balance Podcast. And you also mentioned Instagram is JF Wellness, the letters JF Wellness.
Yeah, awesome. So make sure to leave those linked in the show notes. But otherwise, Jay, thank you so much for coming on the show, man.
Yeah, Lucas, thanks for having me.
Awesome.